Okay, today we're going to talk about nonlinear functions. So you should have that out, printed off. And what we're going to talk about first are a couple different scenarios. The first one is, what if you have a variable that has a squared? Okay, and what kind of graph is that going to produce? So let's just dive in here and do this first example. Okay, so this first example says y equals x squared plus 1. Okay, well, I'm actually going to do this. I'm going to start down here on positive 3. Okay, every single one that you're going to graph today, you're going to use the x values negative 3 through positive 3. And I've written that out on your homework for you, so it's pretty self-explanatory. But you could go beyond negative 3 and positive 3, but for what we're doing, we're just going to do that. Okay, so let's talk about down here with 3. Okay, so it's saying if x is 3, well, what happens if I square x and then add 1? So what's 3 squared? Think about what 3 squared means, right? It means 3 times 3. So 3 squared is 9. 9 plus 1 would be 10, right? Well, what if I take 2 and I square it? Well, 2 squared is 4. 4 plus 1 is 5. What if I take 1 squared? Well, 1 times 1 is 1, plus 1 is 2. Well, then what's 0 squared? 0 times 0 is 0, plus 1 is 1. Okay, did we all follow along so far? Okay, so then let's talk about, well, what happens when you have negatives, right? So if I square a negative, okay, so like right here, I'm doing negative 3 squared. So let's think about, I'm going to draw a little arrow, what that means. That means negative 3 times negative 3. Okay, I put them in parentheses just to kind of like distinguish them a little bit so they don't run together and it doesn't look like a minus sign. But what's a negative times a negative? It's a positive, right? We've done it a million times. Negative times negative, we're ignoring my like half nail polish, is positive. Okay, so negative 3 times negative 3 is 9. What's 9 plus 1? 10. Well, what if I do negative 2? What's negative 2 squared? Negative 2 times negative 2 is positive 4. What's 4 plus 1? 5. And then here, what's negative 1 times negative 1? Positive 1. 1 plus 1 is 2. So what do you notice? Right? When you square a negative, that's the same as squaring the positive. Okay, so we end up with this pattern. So let's see what that looks like on our graph. So now I'm going to graph this ordered pair, negative 3, 10. You don't have to write out the ordered pairs. I'm just showing you where I'm getting it. Okay, so these are obviously my axes. So I'm going to come over here to negative 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And do a dot. Then I have negative 2, 5. So negative 2, 1, 2, 3, 4, 5. Then I have negative 1, 2. Negative 1, 2, and then I have 0, 1. Okay, so obviously this is not straight, right? I can't connect that with a straight line. So let's see what happens on the other side. So I have 1, 2, 2, 5, and 3, 10. Well, it looks like a mirror, right? It's the exact same on both sides. So what we're gonna do, we're gonna connect this with what's called a smooth curve. And what we just graphed, it's a big fancy word, called a parabola. Okay, that is a parabola. And every time you have an equation, a linear equation, or I guess technically nonlinear, anytime you have a function or an equation that has an x squared in it, your graph is going to make a parabola every single time. Okay, so let's look at another one. Okay, this one was a little bit weird because it's like, well, wait, how can I have a negative x squared? Okay, well, essentially what this is saying is the squared is only touching the x. So it's like saying square x and then take the opposite of it, right? Negative is just another way of saying the opposite of. So I know that negative 3 squared is 9, but what's the opposite of that? Negative 9. Negative 9 plus 2 is negative 7. Okay, if you didn't follow what I just did. Okay, so it's saying the opposite of x squared plus 2, right? And I know that when I square -3, it's +9. So then when I take the opposite of that, it's -9. So -9 plus 2 is -7. And then this would be -2 squared is 4, and then it's the opposite of that. So -4 plus 2 is -2. When I square -1, I get +1, but then it's taking the opposite of that. So -1 plus 2 is 1. Can you take the opposite of 0? Nope, it's just 0. So 0 plus 2 is 2. So now, well, what if I square 1? 1 squared is 1, and then we're going to make it negative. So -1 plus 2 is 1. -4 plus 2 is -2. And then -9 plus 2 is -7. So let's graph these points and see what this looks like. So I have -3, -1, 2, 3, 4, 5, 6, 7. Then I have -2, -2. Then I have -1, 1. And then I have 0, 2. Then I have 1, 1, 2, -2, and 3, -7. And so I'm going to connect these again with my soft curve to make the parabola. Okay, and that's what it would look like. Okay, so let's talk about these two parabolas and a couple of things that we can notice about both of them. Okay, so up here, do you see how this is positive x squared, right? Or it's just saying x squared. Because that's positive, it means it's going to open up, right? Do you see how this one was the opposite of x squared? That means it's going to open down. And then look at this second number, right? See how that was 1? Well, look, it's crossing the y-axis on +1. See how this one was +2? It's crossing the y-axis on +2. Okay, it's just a couple cool things about parabolas. But every single time on your homework that you have an x squared, it's going to give you a parabola. Okay, and really quick, if it helps, let me just write this out, and if it does help, great, and if not, that's okay too. But if we have -3 squared, it's always 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Okay, so every single time on your homework, when you're doing -3 through +3 and you're squaring them, those are the numbers you're going to be squaring. So like, for example, this is your homework that I have. Okay, so here, when you're doing -3 squared, you could consult back to here. And just remember it's positive. Okay, so let's talk about the second page of your notes, which is, or are equations that look like this. Okay, and does anyone remember, and I'm asking this like y'all are sitting here in my office with me, which obviously you're not, okay, the symbol that looks like those two, well, it doesn't look like it, the symbol that's just those two straight lines, does anyone remember what that is? Okay, that symbol stands for absolute value. Okay, an absolute value, okay, it would help if you could see that, is a number's distance from 0 on a number line. Okay, and then I'm going to go ahead and put in here always positive. Okay, because you can't have a negative distance. We talked about absolute value at the very beginning of the year, and it's positive all the time because you can't have a negative distance, right? If I walk 5 steps in one direction and then turn around and walk 5 steps the other direction, I still walked 5 steps, right? So when you're measuring distance, it cannot be negative. So that is why absolute value is always positive. Okay, so on this first equation or first function up here, if I have y equals the absolute value of x plus 5. Okay, so let's say x is -3. So what's the absolute value of -3? It's +3. And then 3 plus 5 is 8. What's the absolute value of -2? 2. 2 plus 5 is 7. What's the absolute value of negative 1? 1. 1 plus 5 is 6. Okay, absolute value of 0 is 0. 0 plus 5 is 5. So what's the absolute value of positive 1? 1. Plus 5 is 6. The absolute value of 2 is 2. 2 plus 5 is 7. And the absolute value of 3 is 3. And 3 plus 5 is 8. Okay, so what you'll notice is we still have a pattern, but here it's almost linear, right? It's going down 1, down 1, down 1. Then it goes up 1, up 1, up 1. So let's look at what this looks like. Okay, so I have the point negative 3, right? When I plugged in negative 3 for x, I got 1, 2, 3, 4, 5, 6, 7, 8 for y. When I put in negative 2, I got 7. Negative 1 gave me 6. And then 0 gave me 1, 2, 3, 4, 5. So look, there's like a line. Whoop, I just made it janky, sorry. Okay, and then on this side, when I put in positive 1, I got 6. Positive 2 gave me 7. Positive 3 gave me 8. And it goes this way. Okay, so this is not a parabola, but every time you have an absolute value equation, it's going to make just a general V shape. Okay, so it's going to be linear, like two separate lines coming out from the same vertex point. Okay, and then let's look at my last example. Okay, so on this one, it's 4 times the absolute value of x. So what's the absolute value of negative 3? 3. 4 times 3 is 12. The absolute value of negative 2 is 2. 4 times 2 is 8. 4 times 1 is 4. 4 times 0 is 0. Over here, what's the absolute value of 1? 1. 4 times 1 is 4. 4 times 2 is 8. And 4 times 3 is 12. Okay, so let's graph it. When I put in negative 3, I got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I messed up. Just put it right up there. Okay, when I put in negative 2, I got 8. 1, 2, 3, 4, 5, 6, 7, 8. When I put in negative 1, I got 1, 2, 3, 4. And when I put in 0, I got 0. And then it goes 4, 8, 12. So I'm going to connect it like this. Ooh. Okay, and that is my graph. And if you look at it, it's pretty cool. Well, maybe, I think it's cool. Okay, did I have a y-intercept here? I didn't, right? It was like adding 0. And look where it started, on 0. And what would be the slope, the number that comes in front of x? 4 over 1, rise 4, run 1. Rise 4, run 1. Rise 4, run 1. Okay, over here, the y-intercept would be 5. Well, look, I'm starting on 5. What would be my number in front of x, my slope? 1. Rise 1, run 1, rise 1, run 1, right? So it's like the regular line, and then it's being mirrored on the other side.